I've talked about many general topics on collections, but now I want to get specific, covering the set interface and the classes that implement it. A set is not implicitly ordered, although some implementations of set are. A set contains no duplicates. A set may contain a single null element. Sets can be useful because operations on them are very fast. In actual fact, the lack of duplicates is the most important differentiator, as there are ordered sets, such as the linked hash set and tree set, that I'll review in a future video. The set interface defines the basic methods add, remove and clear to maintain the items in the set. You can also check if a specific item is in the set using the contains method. Interestingly enough, there's no way to retrieve an item from a set. You can check if something exists using contains, and you can iterate over all the elements in the set, but attempting to get the 10th element, for example, from a set isn't possible with a single method. The best performing implementation of the set interface is the hash set class. This class uses hashing mechanisms to store the items. This means the hash code method is used to support even distributions of objects in the set. Oracle describes this class as offering constant time performance for the basic operations, add, remove, contains and size. This assumes the hash function disperses the elements properly among the buckets. Constant time has the big O notation O1. Although I haven't covered the map and hash map types yet, the hash set actually uses a hash map in its own implementation, as of JDK8. Later, when I cover maps and hash maps, I'll swing back and explain how the hash set uses a hash map under its covers. In the video called Setup for Sets and Maps in this section, I created code for a contact class, as well as code that simulated getting phone lists and email lists from an external source. If you decided to skip that walkthrough, you can grab the code from the resources section of this video. I'll be starting with it now in the project called Sets and Maps. I have two classes set up in this code, the contact class that consists of a name, a set of phones which are strings, and a set of emails, also strings. This class has only 3 methods on it. The first 2 are a getter for name, as well as an overridden toString method. There's also a merge contact data method that has a contact as a parameter and creates a new contact. It populates the new contact first with the data on the current instance and then merges emails and phone numbers from the contact that's passed to this method. The second class, contact data, has one method on it, getData, that takes a type, a string, and will return a list of contact instances. The type can be phone or email. If I pass phone, I get a list of contacts each with a single phone number. If I pass email, I get a list of contacts with a single email. The data is stored as text blocks, simulating what each record might look like in a comma-delimited file. Data is read by a scanner instance constructed with one of these text blocks. Every time I call getData on this class, I'll get a new list with new instances of contacts. The main method has a few lines of code in it calling getData on the contact data class. It then uses a method on the main class called printData to print this data out in a neatly formatted way. I'll run this code now. The output shows the 2 lists from the contact data and the contact info printed out. Okay, so now imagine I've got a list of names with phone numbers, with my mobile phone contacts, and also a list of email contacts from an internet provider. I want to combine these contacts, merging any duplicates into a single contact with multiple emails and phone numbers on a single record. To do this, I'll create 2 sets, 2 hash sets to be specific, one for the email data and one for the phone data. Like lists, I start with the interface type as the variable type, so set of type contact in both cases. The first variable, email contacts, will be assigned a new hash set constructed by passing the emails list to it. The phone contacts is the same, a new hash set, but constructed using the phones list. Most constructors of classes implementing the collection interface support a constructor that accepts a collection. You can see this lets me very quickly create a new hash set from a list with 1 line of code. I'll again use my printData method on this class, passing a header and the phone or email contacts. The printData method will take any collection type, meaning any instance of a class that implements collection. This lets me pass any list or a set to this method to get printed. Let me run this. You can see that there are still duplicates in both of these sets, but the order is not the same as the order that was in the list. Can you guess why there's duplicates in these sets, even though I just said on the slides that hash sets won't have duplicates? Well, duplicates are determined for hashed collections first by the hash code and then the equals method. In this instance, both the hash code method and the equals method are using objects implementation. This means each of these instances of contacts is considered unique by that definition. In most cases, this is probably a good thing, but since these are personal contacts, I'm going to make a rule that contacts that have the same name are really the same person, but with different data. To implement this rule, I want to go to the contact class and generate both an equals method and a hash code method. Instead of selecting the IntelliJ default, I want to select java.util.objects.equals and hash code. Make sure the useGetters during code generation checkbox is checked. I'll accept the defaults for the first two screens where all fields are selected. On the third dialog, where it says select all non-null fields, I'm going to just select name here. Let's examine these generated methods in light of what I just previously talked about. First, let's look at the equals method. I've said before that if the references are equal, they're the same instance, and we can return true in that case. Next, the code checks if the object passed is a null or if the types of the objects differ. If either of these conditions is true, then these are definitely not equal. Since the class type was previously checked and found to be the same type as the current instance, we can safely cast the object O to a contact. Notice that for name, which is the only field I said was non-null, the code is directly calling the equals method against what getName returns, which is the name, on both objects. For the other two fields, the code is using another utility class called objects, which is a class in the java.util package. If I control-click on that class name, I can see the comments in the code explaining that this is a utility class introduced in JDK 7. This class provides static utility methods to handle situations like checking for null and comparing objects, etc., suitable for the equals and hash code methods. Getting back to the code, you could guess that a contact is equal based on the name, and if the other attributes aren't null, by matching on emails and phones. Now take a look at the hash code method. Here again, it's using the objects class, calling a hash method on that. I'll control-click on that method next. You can see here that this method takes a variable arguments parameter, and this code simply passes those off to the hash code method on java.util.arrays. Continuing on, I'll control-click that. From this, you see that Java, like IntelliJ, creates a hash code using 31 as a multiplier for each value's hash code. Keep in mind that there's no right way to generate these methods. A lot will depend on your own organisation's standards, but this is a good place to start. I will run my code again, now that these methods are in place. My set still contains duplicate names, but Mickey Mouse only has one entry now for the 999887777 phone number. As you can see, one entry was removed. This means my contacts are unique by the name, all the emails, and all the phone numbers. Going back to the contact class, I'll delete both the equals and hash code method. I'll regenerate these using IntelliJ's default template, but in every instance on each dialog window, I want to just click the name checkbox. In particular, make sure to select name on the last dialog where it's not selected as a default. Here the hash code doesn't use a multiplier, but simply returns the name's hash code. This means a contact instance and a string which have the value Mickey Mouse will result in the same hash code. This is okay, but it's usually a good idea to have objects which aren't the same class type return different hash codes, so I'm going to add my own multiplier here. I'll make it 33, a composite number, but some research indicates that this multiplier can produce consistent results similar to 31. As with almost everything in software engineering, there's debate over what the best multiplier might be. I don't want you to think that 33 is better than 31, it's just a different choice. I know this will drive a couple of my students to go and research that debate, and that's a good thing. For my own small sets in this code, it isn't really going to matter. Now if I run the code again, I get only distinct records by name in each set. My sets no longer have multiple records for a single contact name. Using this method to create my sets, however, means I've lost a couple of phone numbers and emails in the process. To resolve that, I'm going to add two methods to the contact class. The first method will generate and add a company email to the current instance's email set. This will be public, void, called add email, and take a string, company name. This code splits the contact name into an array of strings, splitting on a space. The email is made up of the first character of the name, then the last string in the array, which I'm going to assume is the last name. That's followed by the company name, removing any spaces in it, and finally appending .com to that. Then I execute just the add method on the email set, passing this new string. To test this out, I'll add a call to this method in the main method. I want to first get Robin Hood from the list of email contacts. I can do this by first creating a new contact using just the name Robin Hood now. I can pass this new contact to the index of method on the emails list, which returns the integer index where that element is located in the list. Then I can use the get method on the list to return the original email contact, which is what I want. Now that I've got the original Robin Hood contact, I'll add the company email to this record, calling the add email method with the company name Sherwood Forest. I'll add that statement before the println statement. If I run that now, you can see my method works, and now I have two emails for Robin Hood. One is rhood@sherwoodforest.com. But what happens if I call that method again? Actually, before I do that, I want to change the add email method on contact. The add method on any collection instance returns a Boolean if the element is added successfully. I want to test that result here. I'll remove the emails.add statement and replace it with an if statement that executes the add method on this set and tests the value returned, the negated value. If add returns false, I'll print that the name already has that value in its set, otherwise I'll print that it was added. Getting back to the main method, I'll copy that first add email statement and paste a copy right below it. Running this now, you can see that the first time rhood@sherwoodforest.com was added, but in the second instance the add wasn't successful because that email was already there. A better approach would have been to use the contains method before I did all the work of generating the email string. I'll do this in the next method I want to add, which I'm going to call replace email if exists, a public method with a void return type. This method takes two strings, an old email and a new email. It checks the set to see if the old email is in the set using the contains method. If the old email is in the set, then it gets removed and then adds the new email. In other words, the new email only gets added if the old email is found in the set first, so it's really a replace. Let's say I made a mistake and now need to fix Robin Hood's email, changing it from sherwoodforest.com to sherwoodforest.org. Going to the main method, I'll add this statement after the second add email call. Running that code now. As you can see, I have successfully replaced the company email with the .org address for Robin Hood. Unlike lists, the hash set implementation doesn't include a replace or replace all method. Those are the basic functions on set, add, remove, and contains. There is also no get method on a set. If you want to get an element from the set, you'll have to iterate through every element and look for a match manually. And remember, your hash set's not going to be ordered or sorted. Sets are valuable for groups of elements when you'll be adding elements, removing duplicates, checking if an element is in the list, or other set operations I'll be covering shortly. This isn't the collection you'd use if you mostly want to get elements from your collection and manipulate their values. Okay, so I'm going to end this video here. In the next video, I'll talk about set operations, which are ways to evaluate relationships of elements in different sets.